Hi, Mrs. Moss here. And last time we met, we were talking about minerals and what minerals are. They make up rocks. Well, now we're going to know how we can identify different minerals. There are over 4,000 known minerals on Earth, and we use several different physical and chemical properties to identify and tell them apart. So the first one we're going to talk about is a mineral's luster. A mineral's luster is the appearance that of the mineral as it reflects light, and we refer to its luster as either metallic or non-metallic. Let's look at some pictures so you see what I'm talking about. This is a mineral that's known to be metallic. It has a metallic luster. It looks like a chunk of metal. It's silver and it reflects light in a certain way, so it gives it a metallic appearance. This is a mineral that, although it's shiny and you can see that there is light that's reflecting, it is not metallic. So we call it non-metallic. Here are some more pictures of non-metallic minerals. Although they're shiny, they do not have that metal-like appearance. And in this instance, we see many different minerals, and really the only metallic minerals of this picture that I see are in the center, right around here. These look like they are two pieces of metal or gold, but those are the metallic minerals. The next characteristic that we're going to look at is a mineral's color. Color is used to identify some minerals. Some minerals form in many different colors, and many minerals have the same color. So that's what makes color the least reliable characteristic that we use to determine what mineral it is. And let me show you an example. These four pictures have four different color minerals: white, clear, or even pink. Well, all of these are quartz. So using color alone is a non-useful way of identifying a color. Here's calcite. It comes in many different colors. So we have to use other characteristics to help us narrow down what these minerals are and identify them. Here are all white minerals. Well, these white minerals are all different. One is talc, one is gypsum, one is quartz, and one is calcite. Again, color is the least reliable characteristic that we use to identify a mineral. However, some minerals we do like to use color, and this one is a specific example. Sulfur is always yellow, and olivine is always green. So there are certain characteristics that will be able to use color, but we like to use other things involved with it too, like streak. The streak is the color of a mineral in its powdered form when it's scratched along a ceramic tile or a streak plate. A mineral can vary in color, but it streak the same. That helps you identify the mineral. In this picture, we have hematite, and it is streaking with a red and brown powder left behind on that streak plate. You just rub it against the plate and it produces the powdered color. Here are a couple of pictures of minerals in their powdered form, and you can see the color is pretty similar in these instances to the mineral it came from. The streak is often different from the mineral's color. For example, in cinnabar, we have a grayish mineral, yet the streak that it leaves behind is reddish or orange. And if you look at pyrite, pyrite has a gold color, and it's metallic, but it leaves behind a green streak. So it is a very good way to help us identify a mineral. The next characteristic that we look at is a mineral's hardness. And when we talk about hardness, we are talking about its ability to resist or to be scratched. We use a scale that's called the Mohs hardness scale. And this Mohs hardness scale rates the minerals from 1 to 10 by how hard or soft that mineral is. 1 is the softest, 10 is the hardest. If a mineral has a hardness of 5, like this apatite picture is, that means it can scratch every mineral that's lower on the scale. So apatite is able to scratch talc, gypsum, calcite, fluorite. A mineral's hardness is due to the internal arrangement of the molecules. And if you remember yesterday, we showed a picture of the silicone and oxygen molecules bound together in a mineral, silicate. Well, this internal arrangement of molecules, whether they're loosely packed or whether they're loosely packed or tightly packed, that will help determine whether that mineral will be hard or soft. Here's a picture of a diamond at the top. You can see that the bonds are strong. You can see that it's in a specific arrangement and that it's tightly packed together. These carbon atoms are actually held together and there's a little more space between them and they're a little more spread out, making this a softer mineral of graphite. This is a picture of graphite. It is a soft mineral. And this is a diamond. It is the hardest mineral. Here's some more pictures of diamonds. I just love diamonds. I have to include them in our PowerPoint whenever possible. And this is a picture of loosely arranged atoms. If you look at how they're spread out, it means it's a softer mineral. Whereas this picture demonstrates the molecules more closely packed together. This will have a hard mineral and create a harder mineral. Okay, this leads us to something called cleavage and fracture. First, we're going to look at the way the mineral breaks. Now, breaking a mineral is not usually recommended, and we don't usually use hammers in class to break minerals, but just by looking at the way a mineral is shaped, it gives us a sense whether it has cleavage or fracture. Cleavage is the tendency for a mineral to break along one or more smooth surface. The planes of weakness cause the mineral to break in flat sheets or even planes. I'm going to show you a picture. It's much easier to see than it is to describe. So here's that hammer I was talking about. And when you take this chunk, this big mineral, and you do break it, you notice it breaks in cubes. Well, these cubes have flat, even planes along the sides. The flat sides are what gives it, is what's called cleavage. If a mineral exhibits cleavage, it breaks in a distinct repeating pattern. Cleavage is also the result of the internal arrangement of atoms. Notice how these are underlined. This is important to make sure that you star or underline it if you're in your notes if it's not already done for you. Here are some more diagrams using cleavage, and they're good examples because you could see on the left the way the mineral looks. And then if you look to the right, the yellow diagrams represent the way they break in flat, even planes. That is cleavage. The opposite of cleavage is fracture. And that is when a mineral has a tendency to break in uneven or jagged manner. No smooth surfaces or patterns. And if you look at this picture, it gives a good example of jagged edges without the flat, even plane. Again, if the mineral has fracture, broken pieces are jagged and irregular. So that's all for now. Please go back, review, make sure you have all the notes written down. If you need to press pause and rewind, that's absolutely fine. We expect you to do so. Have a great day, and we'll see you tomorrow.